Hi guys, great to see you. I'd like to welcome us to our channel of Honesty Sciences and Mathematics TV channel. Kindly go to YouTube and search that channel and subscribe. Engage us on the comment section, and also invite more members so that we can have a large community discussing these topics in sciences and mathematics. So today we are going to look at the pH and the other pH scales. In our last discussion on outer ionization of water, of course, we had given it as a reference point in trying to identify substances as either acids or bases. And that was in addition to the previous topics that we had discussed on various definition of acid base from the Bronsted-Lowry definition of an acid base, from also the other definition for Arrhenius definition of an acid base, and the Lewis definition. The concept of auto ionization water gave us a clue on how we can be able to quantify this particular aspect of auto ionization, so that it assists us as a central point for identifying the extent of acidity or alkalinity or basicity of substances. So therefore, in this case, the acidity or alkalinity of substance is going to be determined via the pH scale. And this scale, of course, basically these initials are going to refer to hydrogen potential. And this scale, the pH scale, of course, of a given solution is going to be defined as the negative logarithm. This basically implies to the negative logarithm, and this is from mathematics, a negative logarithm of the hydrogen ion concentration. So we're going to give a negative logarithm of this particular concentration of a solution. So we're going to just have this maybe in form of an equation. And in this particular case, when we're talking about the concept of logarithm, in our case, it's going to be a logarithm to the base 10. So this logarithm is basically going to be log to base 10. We did talk about different parts of an expression for a logarithm. So in our scale, this is going to be a log to base 10 that is defined as the power to which 10 must be raised to give the number in question. So therefore, if we say that the log of 1, then therefore this is going to be log to base 10. And if us is for us to find the answer, then therefore this particular answer is going to be x. So in this particular definition, then therefore we're going to find this logarithm by raising 10 to this power of x in order for us to attain 1. And this basically is 10 raised to a power of 0, which is going to be 1. So therefore log to base 10 of 1 is going to be 0. So therefore on a logarithm scale, the log of 1 is going to be 0 if we consider that this base is basically 10. So that is what the statement is basically trying to imply. So the pH of pure water, as from this particular definition, then therefore we can have it as the pH of pure water. We have indicated a scale of kW for pure water, and then therefore the log of pure water from this particular definition. We had said that we can indicate the concentration of the hydrogen ions for pure water to be 1.0 times 10 negative 7. This was given in moles square per decimeter negative, that one given as such. So in this case, we're going to consider a case whereby, of course, this was at 25 degrees centigrade that we had discussed in our previous discussion. So we're going to consider the case of this pure water, the concentration, and therefore try to consider its logarithm, whereby we're going to give this one as the log of the concentration of these ions is going to be given as. So from the operation of logarithms, we say that whenever we are having a multiplication, for us to get this number, then therefore it's going to be the sum of the logarithms of those specific numbers. So therefore this is going to be the log of 1 plus the log of negative 7, and this is going to be log to base 10 of those particular values. Now if we try to consider, we say that the log of 1 to base 10 is equivalent to 0. So therefore this is going to disappear and therefore give us negative 7. So from the laws of indices and logarithms, whenever we're trying to find a log that is, of course, to base the log of this particular number. Sorry for that. So from this, we are going to have it represented as a pH. I hope this is legible. Let's try to do an adjustment. So the pH of this particular and the pH in this particular case is going to be represented as the negative logarithm of the positive, the H positive ion, which is going to be negative 7. Therefore, this is going to represent 7. So therefore, from this particular case, we can have a general conclusion that the pH scale that is having a scale of a 7 is neutral, and therefore just a general representation for this. So from that particular definition, then therefore from the scale that we are getting, we can have this pH that is equivalent to 7, or the pH that is greater than 7, or rather that is smaller than 7, or the pH that is greater than 7. Then therefore these are going to fall under the category of a neutral solution, and this is going to be an acidic solution. And the last one is going to form a basic solution respectively. So from this particular illustration, the illustration that we have given, therefore we can be able to classify substances that have got a range of scales that are falling under this category as either acidic, basic or neutral. And given that the logarithms are exponents of a log of a product of two numbers is given by the sum of a logarithm of those two numbers, as we had demonstrated, therefore we can be able to try to quantify this Kw that we have mentioned, which basically we had said is an ion product of water. So Kw can be given as the ion product of water, which was the product of the concentration of these two specific ions, which was given a value of 1.0 times 10 negative 14. This was given in the units of mole squared, and this meter negative 6. And for this, of course, we had said that we can be able to get this one, the pH for this as a negative scale. Having talked about the concept of addition and subtraction of logarithms, I can just have that one as a summary as log Kw is equivalent to, of course, the logarithm of the H positive plus the logarithm of the H or H negative, which is going to give us basically negative 14. Now if we consider the negative value for that specific logarithm, and therefore the negative log of Kw is going to give us a value of 14. Therefore we can have a conclusion and say that the P of Kw is going to be given as the P of H plus the P of OH, which is going to give us 14. So basically from this equation, it's going to give us a general view on how we can be able to represent the logarithm, that particular value for the pH of either an acid or a base from this particular general equation, which is going to act as our basis for defining acids and bases on a pH scale. So from this one, I hope that in collaboration with other videos that we have discussed on, especially about ionization of water and other concepts, it's going to give us a clue on identifying acids and bases. And I hope that this is going to be of importance to us, especially in other topics which are going to borrow from this specific concept. So that is it for now, guys. Bye. Catch us in our next video. God bless you.